A lot of this may be a review for you. We'll see. All right, so linear graphs. So the first thing starts pretty easy. It's just breaking down these. Well, actually, before I even do that, I want to do this. So when most of y'all know some of these linear graphs like y equals mx plus b, the standard form is ax plus by, not bx. Ax plus by equals c. But we always change it into y equals mx plus b. Y equals mx plus b. The reason I wanted to talk about this for just a second, so m is the number in front of the in front of the x, the number in front of the x, which is your slope. The words we always think of is what? Rise over run. What this tells us is this, like, we want to think real life here, is this is telling us how much is going up or down and how much is going to the right. So every unit you sell, how much our profit's going up. So you do a positive if it's going up or negative if it's going down. So every minute of exercise, how much more calories you burn, things like that. Like you can look at the slope as the rate of the change. But if it's positive, you go up. If it's negative, you go down. The number on the bottom always tells you to go to the right. The B is your y-intercept. That is my starting point. We're going to do this, I think, in a minute. But does anybody remember algebraically how you find the y-intercept? Like, what do you make x be if you're trying to find the y-intercept? 0. So this is x equals 0. So that is why it's called the starting point, because it's, if you burn, if you do 0 minutes of exercise, how many calories are you burning? If you have 0 products sold, how much money are you making or losing? Like, it is your starting point. The one thing they never define here, or people don't, is the x and the y. Every variable means something in an equation. So x and y is any point on the line. So the x and the y are any point on the line. Anytime you get an equation in a math class or science class, write down what every variable means. Like, just go ahead and put it like right underneath it, because it does really help with word problems, especially in science class and things like that. So it is nice to just know what every variable is, especially when you get to word problems. Other formulas we may see to find the slope, y'all have seen this one. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is two different points. You have two different points, right? You have the first point, x1, y1, and you have the second point, x2, y2. That sub 1 and sub 2 just means you have two different ones. I don't know if you'll see this one, but the y minus y sub 1 equals m times x minus x sub 1. I'm all about trying to keep things as simple as possible, and technically you don't need that formula. So I know everybody taught you all how to do that, but really you don't need that formula. You can use y equals mx plus b for anything that you need. So I may do it that way if that pops up, but I probably won't do that. As far as like formulas on the test, I usually give you all formulas on the test because I don't really think you should have to memorize them. So when we get to the review and all that, we'll see what formulas we need and go from there. All right, so this starts out pretty easy on this stuff, so we'll go through these fast. Finding the x and y intercepts on a grid. So they're literally going to give you a picture and find the x-intercept. The x-intercept where it crosses the x-axis. So this would be 2, 0. That's my x-intercept. And my y-intercept would be 0, 4. That's where it crosses the y-axis. And those are my two answers. Okay, so it does start out pretty easy on these. Sorry, I keep hitting that button. We will start to get into weird looking graphs, but everything is still kind of the same idea. Like, no matter how far you go in math, to find the y-intercept, you make x be 0. To find the x-intercept, you make y be 0. So even on these crazy looking graphs, if you're doing this algebraically, if you're trying to find the x-intercept, we make y be 0. To find the y-intercept, we make x be 0. Here we're just looking at it though. So my x-intercepts are going to be what? 1, 0 and 3, 0. And then my y-intercept is going to be 0, 2. Okay. It is possible to have none too, like it could go and never hit the y-axis. You may see that. They're going to give you a picture like this though, and you just got to identify where it crosses the x-axis and the y-axis. Those should be pretty easy. All right, a table for a linear function. They'll give you a table like this right here, and they'll say, oops. Okay, using the equation y equals 2x plus 1, fill out the table. I'm not going to do all of these, but you just plug them in. All you got to do is plug each of these in. So if you plug in x equals -2. So you do y equals 2 times -2 plus 1. So you have -4 plus 1 is -3. So the point -2, -3 is on that line. This is to show you there's actually 3 ways to graph things. You can pick any point you want for x and figure out what the y is, or you can pick any point for y and figure out what the x is. So that's what this is doing. You could make a list of points and then draw the lines through them. You could use y equals mx plus b, which is the easiest way, which is the way we'll do the most. And then you can graph by the intercepts. You can find the intercept, the x-intercept and the y-intercept, and then graph it. All right, finding outputs of a 2-step function. So this is kind of like a word problem, but it's really just plugging in. So a function, this is our first time looking at a function. This is the function notation. It says a taxi fare is given by this function where d is the miles driven. A function notation, this can be replaced like y. I could rewrite this like y equals mx plus b. But the function notation is an input-output system where you are looking at, okay, if I input my miles driven, it's going to give me out how much it costs to take the taxi, okay? So you put something in, it does something to it. Here we're going to take it times 2.5 and add 3.5. But it is a different type of notation, and technically it's a different line of thought because it's like an input-output system. So we want to know, find f of 4.2. So whatever is inside the parentheses, we're going to plug in for d. So I took 4.2 in there. I'm going to get a calculator for that. Was that 9? 9.5, 2.5 times 4.2, 10.5. So that's 10.5 plus 3.5, so that is 14. So we inputted a 4.2 miles driven, and we outputted $14 for our fare. But I think that's like the only thing we're doing really with functions right now. Maybe do a different notation graphing. We'll talk more about functions later. All right, graphing a linear equation in y equals mx plus b, or y equals mx. So y equals 3x. So this is our first example of graphing. This is like y equals mx plus b. But the problem here is it's like having a plus 0, okay? There is nothing after the x, the 3x. So my slope here is 3. I'm always going to write 3 over 1, write it as a fraction, right? 3 divided by 1 is the same thing as 3. This is positive, so I go up 3, and then I go to the right 1. The bottom number, you always go to the right. If it's positive, you go up. If it's negative, you go down. And then my y-intercept is 0. This is my starting point. Okay? So I'm going to start at 0. I'm going to start at 0. I'm going to go up 1, 2, 3, and to the right 1. So we started at 0, and we went up 3 because it's positive to the right 1. Pausing for a second, letting y'all write. All right, this next one is y equals 2/3 x plus 1. Okay, so same thing. Look at y equals mx plus b. If you need to write it underneath like I am, do that. It does kind of help to see it. So my m is the number in front of x. Every time you get the slope, think about, you don't have to write it down necessarily, but think about what it's doing. It's positive, so I'm going up 2. The bottom number tells me how much I'm going to the right. My y-intercept here is 1. This is my starting point. So I start at 1. I go up 1, 2, to the right 3. And once you get 2 points, you can draw your line. So I started at 1. I went up 2 because it's positive, to the right 3 because that's my denominator. So on this one, I got y equals mx plus b. It's already in that form, so my m is negative 1/2. That means it's negative. First one we've done that's negative. Down 1 to the right 2. And my y-intercept is going to be, I don't know why I switched colors there. Y-intercept is going to be negative 3. Again, that's my starting point. So we start at negative 3, and then I go down 1 to the right 2. So I started at 0, negative 3, down 1 to the right 2. All right, the weird ones, when you have x equals a number, anybody remember what kind of line it is? It is a vertical line. Okay, the way you remember that is if I go, what is this one, x equals 4. If I go over here and I put x equals 4, it doesn't really make sense to draw it this way. What this is actually saying is it does not matter what y is, x is always equal to 4. If y was 10, x would be 4. If y was negative 10, x would be 4. It does not matter what y is, x is always equal to 4. When you do this, the slope is undefined. The slope is undefined. The reason is because if you think about the up or down, left or right, this one is always going up and it's never going to the right. Okay, it's always like you're going up 10 and then to the right 0. So that's like you are dividing by 0, which is undefined. Oh, wait, sorry. I didn't do this one. What just happened? Okay. I need to go back there for just a second. That's fun. All right, if it's y equals a number, y equals any number, it is going to be horizontal. Again, the way you can kind of look at that is if you go to y equals negative 2 on this one, it wouldn't really make sense to draw it this way. So it's going to be this way. And again, this is saying it does not matter what x is, y is always going to be negative 2. And the slope on this one is 0. Because on this one, it does not go up or down at all. It just goes to the right. So if I don't go up or down, if I go up 0 to the right 10, up 0 to the right 10, up 0 to the right 10, it just creates a horizontal line. So 0 divided by any number is 0. All right, to find the x and y intercepts. To find the x and y intercepts, to find the x-intercept, we kind of said this already, you make y be 0. So I'm going to take this equation right there. I'm going to make y be 0. So I do 2x plus 3 times 0 equals 6. I plug a 0 in for my y and solve for x. So 3 times 0 is just 0. So I get 2x equals 6. Divide by 2 and x equals 3. So my x-intercept is at 3, 0. So to find the x-intercept, you make y be 0. And y'all answer this. To find the y-intercept, you make x be 0. So you always make the opposite one be 0. So to find the y-intercept, you make x be 0. So I plug a 0 in for my x. Again, 2 times 0 just kind of goes away. So you have 3y equals 6. Divide by 3 and y is 2. All right, the 4 different kinds of slope you have. I think we've seen all of them already, but just this one problem's on it. You have positive. You always look at this from left to right. Okay. You have negative, so it falls from left to right. There's later on in the class, you have to like read things from left to right. Like what's happening on the left, what's happening on the right. It's falling as it goes to the left. It's rising as it goes to the right. So you have that kind of terminology. And then you've got a horizontal line where the slope is 0 and a vertical line where the slope is undefined. So those are the 4 different types of slope that you see. So if we are given a graph and it's told to find the slope, what you want to do is work left from right, work left to right. So start on the point on the left, point on the left, okay? And then count up or down to that, count up or down to be even to the right, count up or down, and then count to the right. So if I start here, I'm going to go up 1, 2, 3, 4. So I went up 4, that's positive 4. To the right, 1, 2. So my slope here, I went up 4 to the right 2. You can reduce that down to 2. The slope is constant throughout, so I could go up 2 to the right 1. I can go up 2 to the right 1, up 2 to the right 1. It will always work out. It'll stay the same no matter what. All right, finding a slope given 2 points. I think y'all have seen this probably before as well. The y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You are welcome to label these. You have x1, y1, x2, y2. You have 2 x's and 2 y's. It does not matter which one you put first and which one you put second. Like it could be x2, y2, and then x1, y1. I'll talk about what you have to do there, but y sub 2 is 9, y sub 1 is 5, x sub 2 is 4, x sub 1 is 2. So this is 4 over 2 or 2. What you have to pay attention to here is if I put this 9 on top first, that means I have to put this 4 on bottom. Like those have to stick together. So like one of my points is 4, 9, and the other one of my points is 2, 5. So like those have to match up like that. And I'm kind of only doing one of these because I feel like a lot of this is probably review for you. So if you need me to do another one, let me know. All these should be quick. Determine the slope of a horizontal line. We already said this. Since it's horizontal, we know the slope is 0. Determine the slope of a vertical line. So it's x equals -3. Any time it's x equals a number, the slope is undefined. I feel like a lot of these are starting to look the same. So here it tells us the slope is 2 and the y-intercept is 3. So the slope being 2 would be 2 over 1, so that would be up 2 to the right 1. So I'm going to start at my y-intercept. So I start at 3, and then I go up 2 to the right 1. So we started at 3 and went up 2 to the right 1. I feel like I made this section too easy, but maybe not. Maybe we're not supposed to cover all that. Okay, identifying the slope and the y-intercept in this equation right here. Well, that shouldn't be too hard. We don't even have to do any algebra to find it. So my slope is 4, My y-intercept is -2. That's like all you have to do on that. I think I took out all the hard stuff since this is something you should know how to do most of the stuff. It's okay if you don't. That's what this time is for. Graphing an equation, y equals 2x plus 3. So my slope is 2, which would be up 2 to the right 1. My y-intercept is 3. Kind of feel like we've done the same problem. So up 1, 2, 3. So I start at 3. I go up 2 to the right 1. Is that the same one we just did?
Yeah.
I think so. All right, so here is, yeah, there is one of these, okay. So here, write an equation of a line in slope-intercept form with a slope of 3 and passing through the point 1, 4. This is where you are welcome to use this formula if you want to. I know this is probably the way someone taught you, but I'm all about keeping things simple. And everybody knows y equals mx plus b. Something you just remember. We have an m, we have an x, and we have a y. So the only thing we're missing is b. And when you're only missing one variable, you can just use that. So y is 4. M is 3, x is 1. All we got to do is solve for b. So 4 equals 3 plus b, subtract 3 over, and b is equal to 1. So once you have your m and your b, you can do anything you need to. You can graph it, you can write the equation of it. My equation, it would be 3x plus 1. And that's my answer. The reason people like this formula is because when you get done solving it, you already have your answer. But with like fractions and stuff, this is way easier when you get to fractions and stuff. I don't think they have a fraction example on here. If you want me to show you how to do this one real quick, it would be y minus y sub 1, mx minus x sub 1. So you plug the x and the y in for the x sub 1, y sub 1, and then you distribute this. And then add 4 to both sides. So you can see when you get done with it, you don't have to like plug it back in. But I'm telling you, with like fractions and stuff, if we run into any fractions problems, it's so much easier to use y equals mx plus b. It's one less thing you have to memorize. But I don't care. You can do it any way you want to. Actually, let's change this to a fraction. We'll change this problem to a fraction. I'll show you. We're about done anyways. So on this one, it says the slope is -1/2, and my point is 2 to the -1. So I like to use y equals mx plus b. We have an m, we have an x, we have a y. Let's figure out what b is. So y is -1, m is -1/2, x is 2. Let's figure out what b is. So when you go to do this, these actually cancel out on this one, so I picked an easy one to do. But -1 plus b, what you can do is if you, I might do another one in a second. I'll make one up. To solve for b, we add 1 to both sides. Oh, I actually got b equals 0, which is fine. This is still the equation -1/2 x plus 0. I don't think you'll run into too many fractions on that problem, actually, but if we need to do another fraction. With the y minus y sub 1 equals m times x minus x sub 1, you might have to like add and subtract a fraction, which is a pain, whereas here you end up only just multiplying a fraction. All right, word problem. Average rate of change. A car travels 120 miles in 2 hours. Find the average rate of change, which is miles per hour. I think you could actually use, I was going to say D equals RT, but whoa, it took away my, what is it doing? One thing to note here is average rate of change when you're talking about miles per hour, like the word per means divide. So really what you're doing is miles per hour is the same thing as miles over hours. So that's the easy way to think about this one. I'm doing 120 miles over 2 hours. This is the same thing as 60 miles per hour. The word per means to divide. So like the next one, I won't do it because it's pretty easy, but gallons per minute, like you're doing gallons over minutes. This is a topic that is super easy and people actually miss it a bunch because they don't realize it's that easy. But with linear equations, you can do some linear correlation if you're going on to take stats. You'll see a lot of this, but the line of best fit, the linear regression is the average of these points, basically. The average of these points. So all you have to do on this topic, it looks like it's going to be hard. All you have to do is guess what that's going to be and just draw a line in the middle of it. That's it. Is guess what you think the average is going to be. As long as you're close, it'll count it right. And it's saying that looks like that could be the average of those points. Okay? It's just getting the idea of what the line looks like. There are 4 types. I'm scared this one talks about something else, but I don't know. Okay. I'll go back over it if I need to. There are 3 types of associations that we deal with. We kind of talked about these, but this is a positive association because it goes up from left to right. This is a negative association. And then because it goes down from left to right. So just look at the trek. You don't really draw the lines. They probably won't give you the line on this. It's just like, think about what the line would look like. And this one right here, I can't tell which way it's going, right? So this is going to be no association. Sorry, I teach a bunch of stats too, so I don't want to do the linear correlation coefficient, which is R, because that should be a stats thing, but if it does talk about that, we'll come back and talk about that. It's just like how strong of association it is. This is no association though, because you can't tell. It doesn't look like it's going up. It doesn't look like it's going down. There is no association there. All right. This one is, you may run into a couple of these. This is y equals mx plus b. This is just in function notation. So in this class, we do a lot of things with function, but it is just a different notation. Everything kind of works the same way. That f of x is the same thing as y. It's just, like I said, you think about like input and output a little bit differently. So my slope is still 2, up 2 to the right 1, and my y-intercept is 1. Nothing is changing as far as what we are doing. So I start at 1, and then I go up 2 to the right 1. And nothing's changed. It's just a different type of notation that they use. Up 2 to the right 1. And then I think this is the last one. Write the equation with a slope of 1 and a y-intercept of 2. Okay. Seems easy enough. And graph it. Okay, y equals 1x plus 2. So my slope is 1, which means, what, up 1 to the right 1. We start at 2, we go up 1 to the right 1. Up 1 to the right 1. All right.